Hello, so today we're gonna be drawing the molecular orbital for acetonitrile, which is represented here in this Lewis structure. So we're gonna start by writing out 2 carbons. And as we can see in this Lewis structure, this carbon has 4 bonds, which makes its geometry tetrahedral. And since it's tetrahedral, it's gonna have sp3 orbitals. So this is the first one, sp3. There's another one here, sp3. Another sp3 orbital. And what is overlapping between those 2 carbons is an sp3 orbital from this carbon. And for this one, if we can look at the geometry here, its geometry is linear, which means that it's gonna have an sp orbital right here, sp orbital overlapping with an sp3 from the other carbon. And let's not forget the s orbitals overlapping on the sp3, which are the hydrogens, another sp. And the carbon is also connected to a nitrogen by an sp orbital. Like we said, it has a linear geometry, so it's gonna have an overlap of sp orbitals. Let's draw the nitrogen here. And there are 2 pi bonds right here. So for carbon, it's gonna have an pi bond right here. Let's call this py. And nitrogen is also gonna have a pi bond. Let's also call this a py. Let's shade this one. And since we shaded this pi bond for nitrogen, we have to do the same for carbon. And for the other bond, we are gonna draw out here the other pi bond. And we're gonna shade this side, and we're gonna call this PZ. We're gonna do the same thing for carbon. We're gonna draw a pi, another pi bond right here, bond. And we're gonna shade this one and label it as PZ. And as we see here, there is a lone pair on nitrogen, and this lone pair is gonna go right here, and this orbital is gonna be an sp since it's linear. And this is the molecular orbital for acetonitrile.